Let's have some examples on displacement. A particle moves along a circle of a radius r. Here, the radius of the circle is r. It starts from A. A particle starts from A and move in anticlockwise direction as shown in figure. Now, calculate the displacement travelled by the particle and magnitude of the displacement for each of the following cases. In first case, particle move from A to B. In second case, particle moves from A to C. In another case, particle moves from A to D. And in the fourth case, particle moves from A to point A, one complete revolution of the particle. So the distance travelled by the particle from A to B, for this we consider this triangle. For that, the path length is equals to 2 pi r divided by 4. Why 2 pi r? Because the 2 pi r is circumference of this circle, and divide by 4 because we cover a 1/4 distance in circle. So the path length is equals to 2 pi r divided by 4, which is equals to pi r divided by 2. And the displacement is equals to magnitude AB is equals to under root OA square plus OB square, which means under root R square plus R square. It gives root 2R. Now, for the second case, distance travelled by the particle from A to C, which is 1/2 of the circle. In second case, we cover a 1/2 distance. For that, path length is equals to 2 pi r divided by 2. 2 pi r divided by 2 is equals to pi r. And for the displacement, magnitude AC is equals to r plus r, is gives 2r, which gives 2r, where AC is a diameter of a circle. So in the third case, the distance travelled by the particle from A to D, which is 3/4 part of the circle. For this, the path length is equals to 2 pi r into 3 by 4. The path length is equals to 2 pi r into 3 by 4, which gives the path length is equals to 3 by 2 into pi r. And also the displacement AD in magnitude AD is equals to under root r square plus r square, which is OA square plus OD square, is under root r square plus r square, which gives under root 2 into r. Or in the fourth case, for one complete revolution of the particle, from A to point A, for this the total distance traveled will be equal to the circumference of the circle, which is equals to 2 pi r. Therefore, the path length is equals to 2 pi r. The path length is equals to 2 pi r, which is one complete revolution of the particle. And as you know, the displacement is equals to 0 because our particle moves from point A to point A again and complete a one circle. Therefore, the displacement is equals to 0 since the particle comes back to the original position. Here, consider another example. Circle has a radius r. Here, the circle has radius r. An object moves from A to B. Object moves from A to B with angle 120 degree. Then find the displacement from A to B. So here, note down that if you move in a circle from point A to B, suppose here is point A and here is point B, then some angle is created which is theta angle. So if you move in a circle with a theta angle, then the displacement is equals to 2r sine theta by 2. The displacement is equals to 2r sine theta by 2. We will derive in vector portion, but for now you refer that for moving in a circle with a theta angle, then the displacement is equals to 2r sine theta by 2. So put the value of the angle theta, which is 120 degree in above equation, then we get the displacement is equals to 2r sine 120 by 2. 2r sine 120 degree by 2. Then we will get 2r sine 60. The displacement is equals to 2r sine 60. Now we know that the sine 60, which is equals to root 3 by 2. Put the value of sine 60 degree. Then we get the displacement is equals to 2r. The displacement is equals to 2r into root 3 by 2. Displacement is equals to 2r root 3 by 2. And finally we get the displacement is equals to r root 3. The displacement is equals to r root 3. If we move in the circle with a 120 degree from A to B, point A to B, then our displacement is equals to r root 3. Let's take another example. A wheel of a radius r rolling on the road. What will be the displacement of a point P in half rotation of a wheel on the road? So this is a wheel rotate in this direction. After the half rotation, this point P comes at here. We call that P dash. Suppose here is a O. So consider here is our O. So what is the displacement? So here we consider a triangle. Angle is 90 degree. Then P dash is equals to O P square plus P dash O square. Here P dash O is equals to 2r, which is a diameter, and PO is equals to pi into r, because we move half of the rotation. Therefore 2 pi r by 2, which gives pi into r. So for the displacement, P dash is equals to under root pi into r whole square plus 2r whole square, which gives pi square r square in under root pi square r square plus 4r square. And finally we get the displacement is equals to r into root pi square plus 4, and the displacement is equals to r root pi square plus 4. Thanks for the watching.